And I'm now recording. The theme for the first part of this week and this lesson is playing with formulas, and in particularly rewriting them. And I'll show what it means to rewrite a formula here. Rewriting a formula is much like solving an equation, which we've had a little bit of experience with. So the first example that we're going to take a look at is from our blood alcohol content work that we did in the beginning of the quarter. And so let's see, our formula is that B for BAC equals negative 0.015 times time in hours plus this crazy fraction where we take 2.84 times the number of drinks and we divide by a person's weight and gender, multiplied together. So let's take the scenario where we have a male. Whoa, pen's freaking out again. Again, there we go, a male. So that means gender is 0.68 and that their weight is 150 pounds. And then we're going to leave some things variable, like the time and the number of drinks, and just kind of play around a little bit. So rewriting this equation right here, I have to multiply W times G. So I'm going to get a calculator. I've got Desmos here, and 0.68 times 150. Type that right gives me a denominator of 102. Okay, so that's right. Back here. So my formula now looks like this. B equals negative 0.015. I still haven't picked any time to plug in yet. I've got the 2.84 in the top, times N, and weight times gender is, what did I say, 102? Yep. So that's my rewritten formula here. And with this formula, I can do things like say, well, what happens to his BAC? I could make a table. If I pick some time in hours, and I pick some number of drinks, plugging those two things in, then I can calculate the BAC. Like, what's going to happen after 2 hours if this person, this male, has 3 drinks? And so I can just plug into that formula and see what happens. So let's try that. So back to my calculator. This would also be a good application of a spreadsheet. All right, so then I would take my negative 0.015 times, let's see, what did I say, 2 hours plus that fraction, 2.84 times 3 drinks, and divided by his 102 in the denominator, which we get above by taking the weight times the gender factor. And so the BAC formula says, well, if he had 3 drinks, 2 hours after starting drinking, his BAC would be about 0.05. Legal limit for regular drivers is 0.08. If you're a commercial truck driver, it's different. That would probably be over the limit. So I get about 0.05 for the BAC. And we can keep playing around and come up with different numbers. But let's suppose that we're mainly interested in the number of drinks and being below the legal limit. So if I wanted to say, well, what about, we want to just pick, we want the BAC maybe to be around 0.07, right? Just a little below the legal average. I'm not sure how many drinks, but we're going to look, say, 2 hours later. Now, in that case, I can't just plug in, because when I do, I can't use a calculator directly, right? So if I plug in this information here, I get 0.07, that's the target BAC, negative 0.015. I do have T, so I can multiply by 2 there. But over here, just missed my decimal up there, got my my 2.84, I don't have a number of drinks. I'm leaving that variable for the moment. But I should be able to figure it out because that's the only missing thing here. So I should be able to solve for n. So we're going to try and do that, and then we're going to generalize it. So let's take that to a new page. So we need room. 0.07 equals negative 0.015 times 2 plus 2.84 times n over 102. So before we start moving things side to side, what we should do is we should do any arithmetic that we have. And so I would say, yeah, we should definitely do that multiplication. Take 2 times that. I'm pretty sure we'll get negative 0.03. We could double check the calculator if we need to. And then I just recopy everything else. And we have done things like this before in class, especially way back on that lesson. I think just about every lesson we did, we had to solve an equation at one point or another. So usually now I could do that division right there to just get a single number, but that's going to be some premature rounding. So I think I'm going to not do that, but it is a possible option. I think I'm going to get rid of that next. So it's added on. It's a negative number. So to get rid of it, I'm going to have to add it. It's negative. If I add it to itself here to keep the equation in balance here, I have to do the same thing on the other side. And the point here, negative, I lose 0.03, then I gain 0.03. Altogether, that adds up to 0. 0 plus anything is that thing. So on the right side, I've just simplified this down to 2.84 n over 102, and it's equal to 0.07 plus 0.03, which is 0.1. So to get rid of something that's added or subtracted, we have to add or subtract depending on the sign that we see here. Now I have to get rid of things that are multiplied and divided. So we get a multiplication here and a division there. I think I'll get rid of the division first by multiplying by 102. So I'll do the same thing on this side. So then here, that divides out, right? A number divided by itself is 1. 1 times anything is that thing. And then on the other side, I have to whip out a calculator and see what is 102 times 0.1, and you should find that on a good day, that's 10.2. Last step would be to divide to get rid of this multiplication by the 2.84. And again, the reason we do that is because a number divided by itself is 1. 1 times n is just n, 1n. On the other side, this time I need my calculator. So just to double check some of the things I did, I had to take 0.07 and add that to 0.03, and that's where I got the 0.1. Then I had to take 0.1 times 102, confirm that calculation, 10.2. And then now I'm taking that 10.2 and dividing by 2.84. Double check I typed that right in my notes. Yep, that looks like what I wrote in my notes. And all this stuff that I write down, I'm hoping you write all of this down too. And when I grade your test, I'm going to be looking for work like this to confirm you did the stuff yourself. So that division, I'm going to go to 2 decimal places, 3.59. Now remember, this is the number of drinks. So, you know, sometimes people have half a beer, half a drink, half a glass of wine. So this person could have 3 glasses and then they would be under the 0.07. If they had 4, they'd be over the 0.07. If they had about 3.5, they'd still be slightly under because that's 3.5 is just a little less than 3.59. So I would say you end up with a BAC of 0.07% or less, and this was what, 2 hours later? Yeah, 2 hours later. They should have 3.5 drinks or less. Reasonable sentence to go with this. So I'm trying to take into account some of the original information that I was given. Right? 2 hours later, target BAC, and then I calculated N, so what does N mean here? And so on the test, I'm going to be expecting to see that you summarized the information you were given somehow, and then if you had to solve, that you show enough work to justify your answer. And I'm going to ask for a sentence about what the answer means, which I've been asking for in all of the show your works. So those were kind of like practice, writing down work for a test. Questions on this example?
So instead of the 3.59, we would change it to 3.5?
You could write 3.59 too, but like if I was telling this, like suppose this was my brother I was talking to and he said, hey man, I need to be sure I'm like 0.7 or less after this party, because if I get pulled over, I lose my license, I'm screwed.
Oh, that's
you know,
right.
What would I tell him? I would say, yeah, 3.5 drinks. If I said 3.59 drinks, he's not a math guy. He's like, what do you mean 0.59? You know, so I was thinking about writing to, so often when I write my sentence, I think about, I'm talking to my brother, or I'm talking to my mother, or somebody I know that doesn't do as much math as me. How would I explain these numbers to them? And so I usually pick a slightly nicer number than I calculated when I'm putting it in a sentence.
That's right. I remember that.
Yeah, but it'd be fine to write 3.59 too. But if I threw like 5 decimal places in there for the number of drinks, then it starts to look a little weird.
Okay, thank you.
Yeah, good question. Other questions? Okay, so in some sense, this is a review of stuff we covered in lesson 3.2 when we first did this BAC equation. How do we plug stuff into it? We can make tables if we want, where we keep track of different things we enter. And then the extra thing is sometimes if all the variables aren't on the same side, we have to solve. And so today we're just going to be going over how do we solve different equations. And it's pretty similar stuff. We either have to do an addition or subtraction or a multiplication or division, and we just have to do those in the right spot. So today is just practice doing that stuff in the right spot. So there's 4 parts to this lesson. The first part is just playing with the BAC equation. So you're going to, shortly, if you haven't already done it, you're going to do a problem similar to this. So I'm going to move on to the next part. So basically, I'm just doing a summary of each part here. The next part brings up a formula that's used with standardized tests a lot. So formula from standardized tests. Ooh, something's missing there. Standard, there we go. And it's a formula for what's called a z-score. And a z-score estimates about how far from average your score is from others. So it's about how far from average one score is from all of the rest. Like, for example, when I finished high school, I had to take the SAT to get into college, even though I went to community college, which didn't require it, but my advisor said, you got to take it anyway. And then I got a score, and they gave me a couple of different things about it. They told me my score was this number. They said my z-score for that score was whatever, and they also gave me what's called a percentile score, which was what percent of the people scored below my grade. So that's called a percentile, but a z-score would be given also. And a z-score could be positive, meaning you're above average, or negative, meaning below average. So positive is above average, and negative is below average for Z. And so the formula looks like this. I'm just going to write the formula and explain each part. And this is in the lesson and the homework. So that's my crazy z there. And z equals x minus this funky symbol, which is called a mu, divided this one right here is called a sigma. So x minus mu over sigma. Sigma. And these are Greek letters, so that's what I call them. When I see them, I read that as mu, just like I read that as like x, ex. And this thing's called sigma. Mu right here is the average of all of the scores in the test. The x is some person's score. And the sigma is a measurement of the average spread of the data. Right? Sometimes when I give a test, all the scores are close together, like everybody got between 70 and 95. But other times the grades are all over the place, like people scored like a 10 out of 100 and somebody else got 100. So there could be a wide spread to the data, while the data could all be bunched together. So there's lots of different spreads that data have. So when we do a z-score, we need to know the average and the average spread. Now, I'm not going to go over how to calculate average or how to calculate average spread. If you guys take statistics in the future, you'll learn how to do that. For now, somebody will just give me these numbers right here. Like, for example, let's say this was like for an SAT score, and I scored 550. The average was, let's say, 600 for everybody that took it. And then the spread, average spread, was around 200 points. So you can see here, my score is below average. So to calculate my z-score, I would just do my subtraction. That gives me a negative 50. Divide by 200. I guess I need a calculator for that. I think that's what, negative 0.25. So new calculator. So I'm doing a fraction, and I'll just type it as I saw it. 550 minus 600 divided by 200. Yeah, negative 0.25. And sometimes it'll come out to a messier decimal than that. Just kind of depends. So my z-score is negative 0.25. So I'm just have a z of negative 0.25. I'm 0.25 below average based on the spread. Other times, we know a z-score, the average and the spread, but we don't know the person's score. So it could look like this. We could be given that the average, I don't know why I'm writing in red here. That looks like Christmas. Average, that's mu. Let's go with that 600 again. And let's go with the spread, sigma. Let's do 200 again. And let's suppose somebody had a z-score, which we usually just call z, of 1.5. What does that look like in the formula? Well, the formula says z equals x minus mu over sigma, and I just plug in. So this time I was given z, 1.5, equals, I was not given x, so I'm just going to write x. I was given mu, and I was given sigma. So get that in the right spot. There's my mu, there's my sigma, there's my z. Yep, got them in the right spot. And so in this case, I'd be asked to find what the x value is. Find x, which would be the score. I'm talking about SATs. So let's see, what should I do here to solve? Well, this division is under everything here, so I guess I need to get rid of that. So I would multiply by 200, because then that gives me a number divided by itself, which is 1. So I got to multiply by 200 on that side. Okay, so 1.5 times 200, I think is 300, but I'm going to double check. 1.5 times 200, yep. Head is going okay today, it doesn't always go that way. 300 equals, and I got rid of the 200 in the bottom, so I just have an x minus 600. All right, oops. So to get rid of that minus there, I'm going to do a plus. So I'll add 600. and add 600. So minus 600, so I lost 600, I gained 600, so that's a net 0. So I just have now x is equal to 900. So just to double check, a positive z-score means they're above average. So a score of 900, yeah, that's above average. And according to the spread, it's a z-score of 1.5. So that's how I use that. Now, in general, it doesn't matter what numbers people gave me, this process right here works exactly the same way each time. So if somebody gave me a different set of numbers, like suppose someone said, okay, the z-score was negative 2.1, we don't know x, mu is 7, and sigma is 1.5. Suppose I was given that information right there. And the steps I take are exactly the same. First, I'm going to get rid of the denominator. So I would multiply by 1.5. Usually where there's a minus, I put parentheses to be clear. I'm multiplying, not subtracting there. And again, the point of this is a number divided by itself is 1. 1 times anything doesn't do much. So that's just x minus 7. Need a calculator for that right there. 1.5 times, just missed something there. 2.1, 3.15. Positive times a negative is a negative. So that would be negative 3.15. And then to get rid of subtraction, we add. So then I would add 7 here, add 7 there. Now that I gotta be careful because I have a negative positive. Let's see what x is. Oops. I'm gonna type it as I wrote it. Negative 3.15 plus 7. Oops, I'm not in the calculator. Again. That's right, 3.85. So according to that right there, it looks like x is 3.85. And I could always check by plugging back in. That's the nice thing about playing with these formulas. What if I take x as 3.85, subtract that average of 7, and divide by the spread of 1.5? I better get that negative 2.1 back. So let's double check. So we got to get good with our calculators and realize we should check stuff once in a while. So fraction, let's see, 3.85 is what we think x is. And then from that, we subtract the average and divide by the spread. And I got negative 2.1, which is right what I was supposed to get. So you can always back up in a formula and check that the number you calculate works. So again, the process here was I had to do a multiplication by the denominator first, and then I added that number over to the other side second. And it just works that way all the time. So if somebody didn't give me any numbers, but I know that I'm going to have to solve for x often, then I could just make up a new formula for x by solving this for x. So just like before, the first thing I did was get rid of the denominator. So I would have to multiply by that funky sigma thing. So what is that? Well, it's just sigma times z or z times sigma, whichever order you want. A number divided by itself is 1, so now I just have x minus mu on the other side. Right? These are the same steps we did. I'm just using that letter instead of a number, and I can't simplify that because I don't have numbers yet. What did I do next? Well, I got rid of this minus by adding, so then I would have to add that to each side. And since I don't know what they are, there's really not much to do besides say, okay, we have sigma z plus mu. That's all we can do with it. So this is another version of that formula, but this one is useful when I need to find x. This version is useful when I need to find z. So we have two different versions of the same formula. And that happens a lot in different situations. Okay, 2 more examples, and then you guys are gonna double check answers together. distributing and factoring. So in some previous class, maybe it was the one before this, Math 62, maybe it was some other math class you took, you learned about distributing, which is when you have some number outside of a parentheses, and then there's an addition or a subtraction inside the parentheses. And the distributing means is this 2 times out here is really times both of the things inside. So that gives me a 2 times x minus a 2 times 3. Right, so moving in this direction is called distributing. What we're going to learn to do right now, and maybe you've seen this before, is take that in the reverse direction, and that's what's called factoring. So if I started with something like 2 minus x, I could realize that, well, that 2x is really 2 times x, and the 6 is really 2 times 3. And on each side of this subtraction here, there is a common factor of 2. And so what I can do is I can make a note that, hey, there's a 2 that's common to both things on each side of that subtraction. Now, if I pull that 2 out, so factoring is like dividing. What if I took this 2x here and divided it by 2? Well, 2 divided by 2 is 1, so that would give me just an x. And what if I took this 2 times 3, which was a 6, what if I divided that by 2? Well, 6 divided by 2 is 3. So factoring is like dividing. You decide what the common thing is you can divide out, you pull it out, and then you divide to see what's left there. And so we're going to practice this on a couple more problems, and I'm going to show a place where it's really useful. So another example is if I had something like, let's try 12x minus 16. So there's a couple ways you can factor this. Somebody might look at that and say, oh, both of those are even, so I could factor out a 2. Then I divide by 2. What's 12 divided by 2? Well, that would be 6, and there's still an x. What's 16 divided by 2? That would be 8, and there's a minus in between. And then you might look at this and say, oh no, they're still even. I could do that again, right? So that's partially factored. Because we could divide out more. And some days I'm good at seeing the full thing I can factor, and some days I'm not. So then I realized, okay, so I could factor out 2 twice in a row, which is like factoring out a 4. So 12 divided by 4 is 3, and the x is still hanging. 16 divided by 4 is 4, and there's a minus in between. Now 3 and 4 have no common factors, so now I think I'm done. So although this has been factored and that has been factored, the first one's only partially factored because you could still factor more out. This one right here is completely factored. Completely. There we go. So one more example, and then I'll show you the more interesting problem. If I had 3x squared plus 18x. Now, looking at this right here, I'm saying, okay, wait, I remember 3 goes into 18, and they both have x's in there. So I can take out both a 3 and an x. Now, x squared really means x times x, right? So I'm taking the 3 out and one of the x's, which leaves an x behind there. 18 is really 3 times 6 times x. I'm taking the 3 and I'm taking an x, which leaves a 6, and then the connection was addition. Now, every once in a while, I screw that up, I make a mistake. We can always check by distributing. So I think this is my answer. And to check it, I would just distribute and see if it matches. So take the 3x and multiply it back through. So 3x times x, well, x times this is x squared, so this would be 3x squared. 3x times 6, well, 6 times 3 is 18, so that should be 18x. Does it match what I started with? Yes. So sometimes in order to solve something, I need to factor, undistribute. And so we're going to take a look at an example that we need to do that. That example is from simple interest. So the way simple interest works is given some interest percent, we can calculate an interest amount. So we have an interest percent, and that leads to an interest amount. So for example, if somebody told me that the interest rate, some investment was 3%, we usually call the interest rate R for rate. And then the amount of money I start with, we usually call that the principal. So the starting amount is sometimes called principal. Principal, not an AL, that would be like the guy in charge of the school. That's the amount you start with, and maybe I'm going to start with like $500. And usually we give that the letter P. And then time has to go by, and usually the time for an interest rate is a year, but it could be a day or a month. Like with credit cards, they do an average daily balance, and they also do a monthly collection of interest. So the period of the interest, that varies. So I'm just going to say this is an annual percentage rate. And what that means is I would get 3% per year. So if 1 year goes by, I get 3%. If 2 years goes by, I get another 3%. So that'd be 6% and so on. So let's say 2 years went by. The formula looks like the interest amount is usually called I. So I is always equal to the principal times the rate times the time. So for me, I would take my $500, multiply it by 3% as a decimal, and then multiply it by 2 years went by. And remember, the percent symbol here, literally, those are the 2 zeros from 100, and that's a divide. So 3% literally means 3 divided by 100. Or maybe you want 3/100. If you whip out your calculator and say, hey, what's 3 over 100? Your calculator is going to say it's 0.03. And remember, that's the 10th position there. That's the hundredths position there. So 0.03 is slang. The proper way to read that is 3/100ths, like I wrote over there. So to be safe, whenever you're converting a percent to a decimal, just whip out a calculator and divide by 100 to be safe. So I'm going to whip out a calculator on this sucker right here. So double check 3% literally means 3 over 3 divided by 100. My calculator says, yep, that's 0.03. 500 times 0.03 times 2, this says I would get $30 interest after 2 years. So if this company said, hey, let me borrow $500, you invest $500, and we'll give you 3% per year interest. So at the end of that, they owe me the $500 and they owe me another $30. So this comes out to $30. And that's the interest amount. The interest rate, again, was the 3%. Now, altogether, we get this future amount, right? And the future amount is whatever I gave them plus the interest. So writing that in red to emphasize it, to calculate the interest, I take that principal, multiply it by the rate and the time. So if I put all of this together, we use F for future value, and that equals the principal plus the interest. And the interest is always P times R times T. For this situation, I started by investing $500, and then 2 years later, they owe me 500 times 0.03, the rate, times 2 years. That right there all came up to $30. So altogether, they now owe me $530. Okay, so that's just using this formula. Okay, so this is simple interest formula with the original investment tacked back on. Sometimes things go the other way. Like perhaps I know I want the future value. Let's say I wanted a future value of $600. Okay, here my future value is 530. And let's leave everything else the same. Well, since I know the future, I don't know what the principal is in theory. So principal P is unknown for a moment, but we're going to stick with the same rate, 3%, and the same time, 2 years. And if I fill out the formula with this information, the 600 goes where the F is. So I get 600 equals P plus P times 0.03 times 2. And solving this, so the next thing I would need to do is solve for P. The problem with solving this is there's more than one P. When we've solved other equations for like N or T or X, there was only one of them. What the heck do I do when there's two of them? Well, that is where this idea of factoring comes in, because I can reduce the way I see the variables. And so that's what we're going to do here next. So here's where I'm at with this situation. I now have an equation that says 600 equals P plus P times 0.03 times 2. And I mentioned before, when we're solving equations, if you can clean up something before you move stuff around, do it. So I might as well do 2 times the 0.03. And double check in your calculator, that should be 0.06. So now I have 600 equals P plus P times 0.06. And here's where factoring comes into play. There is a P common here and there, so I can factor that P out. To see what's left, it's like dividing. So whatever's left here is P divided by P. Well, a number divided by itself is 1. And the number that's going to go here on the other side of the plus is whatever I started with, but dividing by the P, because factoring is pulling that out. And if we pull that P out or we divide by it, we just get 0.06. So then I can add those two numbers. That's just 1.06. So I get P times 1.06 equals 600. And we know we can break that multiplication there by dividing. A number divided by itself is 1, right? So now P is whatever that is. So let's calculate it and check it. So I was hoping to have 600, and the formula I solved says I should divide that by 1.06. And that means I should have invested $566.38. I would round that to 0.03, so 4 cents, 566.04 would be the correct rounding there. So wavy equals, because I had to round, $566.04 is what it looks like the initial investment is. So I think that's my answer. Invest $566.04. 3% for 2 years to end up with $600. Is that really true? I guess I better check. see. I think that's what that number means. To check it, I just go back to this original equation and plug in what I think P should be. So I think P should be 566.04. Add that to 566.04 times the 3% as a decimal times the 2 years. Plug this into a calculator and pray. Let's do it. Yeah. All right, so let's see. 566.04 plus 566.04 times 0.03 times 2. Oh, decimal point. And I get about $600. Now notice, because I rounded up here, I rounded up, I ended up with a little over $600. But close enough. It worked. All right, my turn to shut up and let you guys play with the lesson.